Yeah, I mean, this one is a clear and cut case because, e to the x and e to the 5 plus x, you could just rewrite uh, whether they're linearly independent or dependent on their. By the way, when they say where for all x where the functions are defined, they just mean on their domain.
Right.
And in this case, the domain is all real numbers. Okay, because there's no restrictions um, on the domain. So you could rewrite e to the 5 plus x as e to the x times e to the 5.
Yeah.
Right?
Yeah.
And you can certainly multiply e to the x by a c1 added to some c2 e to the 5 e to the x where there's 0 by simply coming up with c1 and c2 that are not necessarily 0. Like all you need to do is make those negative of each other.
Yeah.
So if c1 equals minus c2 e to the 5, so you can potentially make, I mean, there's many ways to do it. You could call c2 to be 1, and therefore in that case c1 would be minus e to the 5. Or you could take their ratio like he said, and their ratio would be constant. So there does exist c1 and c2, at least one of them, that are non-zero, for c2 to be 1 and c1 to be negative e to the 5th, that would make the sum of both of them 0 on all functions of x in the domain. For any value of x, that would work. So therefore, since we were able to find something that's not 0, they are linearly dependent. Okay, good. Any questions on that? Okay, we could move on to the next one.